All right, so this is problem 56 of the week 5 video explainers. So in this case, there is an individual sitting on a bench in a car, and it is very slippery. That is what the problem states. So the meaning that there's no friction, and also the person does not have a backrest or anything from them to hold on to. So in this case, we can draw a picture of the person sitting on the bench, and we can see that there's a normal force acting on them and the force of gravity. So due to the fact that there's no friction and they have nothing to hold on to, this eliminates any forces in the either x direction. So the only forces that are going to be in them is the normal force and the force of gravity. So that's going to show that there's no net force on them due to the fact that they're moving at a constant velocity, and also to the fact that they're not experiencing any friction. So in this free body diagram, we can see that the normal force is moving in the positive y direction, and the force of gravity pulling them down in the negative y direction. So this normal force is going to be the force perpendicular to them. So for part C, this is going to be the same, except now the car is slowing down. So there's not going to be change in the vertical direction, and there's not going to be change in the x direction. Essentially, it's going to be the same because the bench is frictionless and they have nothing to hold on to. And like we said, there's no motion in the vertical direction, so the normal force and the force of gravity is going to be the same. So that free body diagram is going to be the same as it was in the initial state when the car is just moving at a constant velocity. So what would happen when the car slows down? So eventually you'd end up flying out of the car, because if you're using the person as a frame of reference, there's no change to them. However, the velocity of the car is going to be slowing down. So ultimately you will be moving faster than the car. So you will fly out of it or just be thrown forward. So Newton's first law, it explains that so you will continue to move with the same velocity when there are no forces acting on you. So in this case, like we mentioned earlier, when the car is slowing down, there are no forces acting on you. That being said, that your condition is staying the same. However, the car is slowing down, so it will seem as if you're thrown forward. That being said, there are no horizontal forces, and the vertical forces are balanced. So there's no force that is pushing you out of the car, but it's rather that due to the fact that you're moving faster than the car, you will be thrown out. So now in this last part, the problem states that the benches are not slippery. So we can infer that there's some type of friction on the bench. So this new frictional force is going to be opposite direction of your movement. So in this situation, the person was moving in the positive x direction. So now the friction force is going to be moving in the negative x direction, opposite of the movement. So in this new free body diagram, the normal force and the gravitational force is going to be the same. However, now that the bench is not slippery and there is a friction force holding you back, there's a new element to the free body diagram, and that will be the frictional force moving in the negative x direction. So a couple things to note from this problem and how it connects to the week is that previously we've just only been talking about vectors, and now that there's a new component that we can add to all of this, is that there's going to be forces that are going to be being applied to the objects in question. And some of the tricky parts in this problem was mostly just everything is cleared up. I feel as if you can draw a free body diagram and know in what direction on each axis the person is moving, it makes identifying the forces a lot simpler. And yeah, for the most part, here just drawing the diagrams really clears everything up and allows you to solve the problem with a lot less frustration.